Okay, so this is going to be our first lesson on improper integrals. Okay, first to recognize them. So integrals, such as the integral from a to infinity of f of x dx, or let's say negative infinity to a is just some number. And then you have the double whammy, which would be negative infinity to infinity, are called improper integrals. Okay, now, to evaluate them, here's what's going to happen. You're going to replace infinity with a letter like b. Okay, so let's take a look at an example. And then you're going to get the limit as b goes to infinity. All right, so here's an example. Example 1. We have the integral from 1 to infinity of 1 over x dx. So what we do is we take infinity and we replace infinity with a letter, say b. So we make b go to infinity. So then we have the limit as b goes to infinity of the integral from 1 to b of 1 over x dx. Okay, so then you do that integral. And that integral, this is a definite integral, so it's ln absolute value of x. Absolute value is not needed here because it starts at 1, from 1 to b. So that would be the limit as b, the limit as b goes to infinity of ln of b minus ln of 1. Well, ln of 1 is just 0, so don't worry about that. So you need to think about what is the limit as b goes to infinity of ln b, right? Where does ln go? Think about the graph of ln. As you go to infinity, it approaches infinity. It takes a long time, but it does approach infinity. Now, what we say, just to give you a heads up, because we're going to be going into series tests, when you get infinity, that means that the integral diverges. Diverges means that you're not going to be able to peg down that area, okay? All right. So the area is infinite. Let's look at another example. Okay, I think these are pretty looking, don't you? You can just decorate your notebook with these. So we have the integral from 1 to infinity of e to the negative x dx. So I'm going to get the limit. I'll do a this time. It doesn't matter what letter I use. As a goes to infinity of the integral from 1 to a, e to the negative x dx. Now the integral of e to the negative x is just negative e to the negative x. Let's put in our bounds of integration, 1 to a. So we get the limit as a goes to infinity of negative e to the negative a minus e to the negative 1. Okay, so let's put these in the denominator. So we have the limit as a goes to infinity. I have negative 1 over e to the a minus 1 over e. Okay, well, think about the graph of e to the x, right? That goes like this. Okay. So if a is going to infinity and you do negative 1 divided by e to infinity, that's going to be bottom heavy. So bottom heavy goes to 0, right? So the answer is just negative, right? So we just have a, did I put in these bounds correctly? Upper bound minus lower bound, yeah. Okay. Okay. It's fine. You guys, I made a careless error here. Upper bound minus lower bound. I forgot minus and negative. Made a careless error, so that should be plus. Okay, I knew I did something wrong. So the final answer is just 1 over e. So what that means for you, if you look at the graph of e to the negative x, so this should make sense to you that this area would be bounded, that it would be finite, all right? Because if you look at this integrand, think about the graph of that. Okay, e to the negative x, okay, like if you plug in -1, right, that's going to be just e. So it's the reverse of e to the x. That was e to the x. So this is e to the negative x. So it makes sense that if you're starting at 1, right, and you're going to infinity, that eventually that area has a possibility of ending. So it does actually end. Okay, and that area is equal to 1 over e. Okay, let's look at one more example. 2 more examples, I lied. Okay, example 3, negative infinity to 0, e to the x over 4 dx. So we're going to get the limit. Okay, I'll make this a going to negative infinity of the integral from a to 0, e to the x over 4 dx. Okay, so as you know, when you integrate that, okay, you're going to get e to the x over 4. You have to compensate for the rate times 4, right? Because remember, that's a derivative, so. Okay, so we have to go from a to 0, limit as a goes to negative infinity. So we get the limit as a goes to negative infinity, and then that's going to be 4 times e to the 0. If you want to be bothered writing it, go ahead. Minus 4 times e to the a over 4. Okay, so for the first part, we just get 4. And then for the second part, you have to be careful here, because you're going to have negative infinity divided by 4. The 4 is pretty irrelevant when you're dividing infinity by something. So that's going to end up looking like this. The limit as a goes to negative infinity, right? 4 minus 4 times e to the a over 4. Okay, but then think about this part. 4 e to the negative infinity is 4 over e to infinity, which is bottom heavy. Okay, so that goes to 0. So therefore the answer is 4. Okay, last question. Let f of x equal e to the negative x, and let R be the region in the first quadrant between f and the x-axis. Find the volume when this region, R, is revolved around the x-axis. Okay, so if you draw a picture of this, we have e to the negative x. Okay, we just want the part in the first quadrant. And so we're revolving this around the x-axis, so we get these little discs, right? Okay, so that's the way you get your volume. Oops. Okay, anyway, so volume is equal to pi, okay, r squared, from 0 to infinity. And so that's going to become, okay, pi times the limit as a goes to infinity of the integral from 0 to a of e to the negative 2x dx. So that becomes negative 1/2 on the inside, right? I could factor that negative 1/2 out if I want. Times the limit as a goes to infinity of e to the negative 2x bar 0 to a. So that's negative 1/2 pi. And then we have the limit as a goes to infinity. So that's going to be e to the negative 2a minus e to the 0. But this e to the negative 2a is going to end up being negative 2 times infinity. Some infinities are larger than others, okay? It's just a concept, infinity. So this is going to end up being 0. And then that is 1. So we end up with negative 1/2 pi times negative 1. So therefore the volume is pi over 2. And they typically like to do that, all right? This way they can ask you 2 topics simultaneously. All right, thanks, kids.